Good morning. This is a class on solving problems on increasing and decreasing function. Definition you already got. This I have explained graphically also some parts of it. So this time I am going to solve many problems so that you can apply the concept in solving other problems given in your textbook. So let me take the example 1 today's class as find the interval in which the function fx equal to, say I am taking sine 4x in 0, pi. Find the interval in which this function is increasing or decreasing in 0, pi. I told you in the last class that functions may be only increasing or only decreasing. In one interval, it cannot be both increasing and decreasing. Okay. So when we are going to consider this kind of function, there are many critical points on the number line. So you have to draw the number line and then you have to decide the signs in various intervals and then you continue. Okay. So for solving this problem, first I am going to find the critical points. So for finding critical points, put f dash x equal to 0. What does this imply? This implies that 4 cos 4x equal to 0. So cos 4x can have value pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and 9 pi by 2. All of you understand? But why have I stopped there after 9 pi by 2? Because if I go on finding the values of x here, that x is going to be pi by 8, 3 pi by 8, 5 pi by 8, 7 pi by 8, 9 pi by 8. 9 pi by 8 till that you need not consider because the interval I have given 0 to pi. So your next step will be just to plot these points on the number line. Okay. These are the points here. I am taking 0 here. Then this is pi by 8. This is 3 pi by 8. 5 pi by 8. 7 pi by 8. 9 pi by 8. But you won't consider 9 pi by 8 point. We will restrict our interval up to the point pi. That is obviously a point lying in between 7 pi by 8 and 9 pi by 8. So now our aim is to consider the signs of which one? Signs of f dash x. That f dash x we have calculated before. F dash x here it is 4 cos 4x. Now how to decide the sign of 4 cos 4x on this interval? So I'll suggest you to take the shortest interval and then go for alternate plus and minus sign. Okay. Suppose I am taking say pi by 8 to 3 pi by 8 in this interval. Okay. So when x greater than pi by 8 less than 3 pi by 8, this implies that 4x will be greater than pi by 2 less than 3 pi by 2. What is the sign of 4 cos 4x in this interval? Because this interval is going to be this thing, pi by 2 to 3 pi by 2. This is the quadrant. Here, which two quadrants are involved? The second and the third quadrant. In second and third quadrant, 4x is going to be negative. So put negative signs over there. This will be minus. Oh, sorry. I have taken this interval, no? So this will be minus, minus, minus. This will be plus, plus, plus. You need not check even. I am suggesting you this method. This is a very good method. You need not determine the sign by putting the intervals this way. And I am telling you this one as a textbook method. Nicely it is explained in the example. You can verify my way of calculation with the textbook solutions. Okay. So for this sum, increasing in the interval, the function is increasing when x is belonging to 0 pi by 8. Never forget to put open bracket over there, because close bracket means that is not strictly increasing. Unless otherwise stated, you will always take strictly increasing part. So this will be 3 pi by 8, 5 pi by 8, and then union 7 pi by 8 to 7 pi by 8 to pi. So this interval, it is going to be increasing, and it is decreasing when x is belonging to pi by 8, 3 pi by 8, union 5 pi by 8, 7 pi by 8. Okay. So this method you must keep in your mind for finding the interval where it is increasing or where it is decreasing. Let me explain another similar problem that today's class will be example 2. Find the interval in which f(x) equal to sin x minus cos x is increasing or decreasing in the interval 0, 2 pi. I have taken longer interval because you may be confused if one interval, I mean just one critical point you obtain there, then you know that all questions will be of that kind only. This is not the case. There may be many intervals involved where you have straight increasing or decreasing property. Okay. When we are going to solve here, the same procedure I am going to apply for this sum, that you first find the critical points. So for critical point, we will be putting f dash x equal to 0. Find f dash x equal to cos x plus sin x. This is nothing but, all of you know, root 2. 1 by root 2 cos x plus 1 by root 2 sin x. Root 2 cos x minus pi by 4. Now next step is find critical points. Put f dash x equal to 0. This implies cos x minus pi by 4 equal to 0. So x minus pi by 4 going to be pi by 2, 3 pi by 2, 5 pi by 2 you won't take, it is more than that. But, okay, you take 5 pi by 2. So, x is going to be what? 3 pi by 4, then 3 pi by 2 plus pi by 4, that is 7 pi by 4, and next one 5 pi by 2 plus pi by 4, that is, but this is not the case because 0 to 2 pi is only involved here. Okay, so again by the same manner I'll be plotting the number line here, that those points are going to be 0 here, then 3 pi by 4, then 7 pi by 4, then 11 pi by 4, somewhere like this, but we don't want to take it into the interval, we'll be taking up to 2 pi, it lies in between. Then what method have I told? Take the shortest interval when x greater than 0 less than 3 pi by 4, we have this thing, x minus pi by 4. X minus pi by 4 is going to be greater than minus pi by 4 less than pi by 2. So which interval is this? This is a part of fourth quadrant to the first quadrant, something like this. And in this interval fully, cosine function is positive. So cos x minus pi by 4 is positive here in this quadrant. Okay, so I'll be putting plus sign. Then the same technique, alternately it will come plus and minus. Verification will waste your time, so I will not suggest you to do. Just put alternate plus and minus. So it will be increasing when x belongs to 0, 3 pi by 4 union 7 pi by 4 to 2 pi, and decreasing when x belongs to 3 pi by 4 union 7 pi by 4. Okay. Now another sum I am taking, I'm writing at number 1, 2, 3. This one is a continuation of the first class, where I have taken this example from your textbook. Prove that y equal to log of 1 plus x, 2x by 2 plus x, x greater than minus 1 is an increasing function of x. When you are going to solve this, you know the first step what to do. You take dy by dx only. All of you can find it. Dy by dx is going to be 1 by 1 plus x minus 2 plus x whole square, 2 plus x into 2 minus 2x. This thing will give us 1 by 1 plus x, 4 by 2 plus x whole square. But there is a minus sign. So now you have to add these two. So on adding these two, it will give us x plus 1. So there will be x plus 2 whole square. And all of you can see that here numerator has become a quantity which is perfect square. Denominator also partly perfect square. So sign of dy by dx depend on, so you'll write your comment here, sign of dy by dx depend on x plus 1 only. All of you will agree with me because other terms are perfect square. So fx is increasing. Y equal to fx is increasing when x plus 1 greater than 0, that is x greater than minus 1, and it is decreasing when x less than minus 1. Okay. One similar question is there, that is also in the textbook, that y equal to 4 sin theta that divided by 2 plus cos theta minus theta in the interval 0, pi by 2. In 0, pi by 2, again you start the same manner, that you take the derivative of the function first. So when you take the derivative, it's going to be in terms of theta. So differentiating with respect to theta, dy by d theta going to be my suggestion for this sum, because I have the experience to differentiate separately. All of you can see, all of you can realize that also, because when you merge theta with it, it brings nothing but more complexity in the sum. So don't do it. So 4 cos theta, this minus 4 sin theta into minus sin theta, this minus 1. Okay. All of you can see how this part is being separated from there. Decision making will be easier for you. Okay. So this is just the way I did before. I am applying the same technique. I found this the easiest one for you. That's why 4 sin theta cos theta. Look at the expression here. When you differentiate, this has become 2 plus cos theta into 4 cos theta minus 4 sin theta into 0 minus sin theta. So if you merge these two, this is going to be 8 cos theta plus 8 sin theta cos theta minus 1. So there it will be 2 plus cos theta whole square, 8 cos theta plus 8 sin theta cos theta, this minus, this will be 4 cos theta plus 4 cos square theta. Okay. Now if you merge these two, this is going to be like this. This is 4 cos theta minus 4 plus 8 sin theta cos theta minus cos square theta by 2 plus cos theta whole square. Okay. Now you can decide the sign quickly by taking cos theta is common. That part is going to be greater than 1. This part also going to be greater than 1 in 0 pi by 2. This will be always increasing function. You can verify it yourself. Nice. Okay. Just put your effort in completing the sum.